Good morning, everyone. I appreciate you coming this early in the morning. Not so easy for a software developer waking up before 9 in the morning. And I know that. I feel your pain. So we are here to talk about concurrency and unit testing. Before that, for those of you, I see a lot of familiar faces from the last 2 days. So shortly, I'm a consultant at Code Value. Been developing software since 2002. At least been paid for it since 2002. And in my past, I worked for TypeMock, a company that specializes in unit testing and create a mocking tool, which I talked about yesterday quite enough. So we'll put it there. And I develop code using test-driven development for about any project I get, because that's the way my mind works. After a while, I can't do that any other way. And I'm a big believer in clean code and anything else that can help us developers write better code with less bugs, or any bugs for that matter. I have a blog at blog.drorhelper.com. Now, let's do an exercise before we start. This is actually something I used to give applicants. This is an actual test I used to do, because people come to a job interview, they are a bit stressed out, and you want to give them something pretty simple to start with. And I would show them this code or something similar to it. And I see, by your looks, that's exactly the look I would get, because people think there's a trick. So the first thing I say, what this code does, no trick. I promise you no trick. So what does this code do? What, if I'll print count in the end of it, what will I get? Well, we are starting from 0 till 10, probably, this case, yeah, 10. So that's good enough. Yeah, that is the right answer. And then I'll show him the following code and ask him, now, what do I get? And in that moment, after being very calm from the first answering this question, they'll see that. And once threads get into the equation, now we don't know, right? Who here think that the output is undefined? I can't possibly know. Anyone? You can raise your hands. You're not in a job interview, so. Well, true thing is the output is well-defined, very well-defined. Basically, most of the time I'll get 20 because I'm running it twice. And some of the time, depending on my computer, it changes, I'll get something between 10 and 20. And to prove that, I'll run that code. And as you can see, most of the time it's 20, and I get 11, 14, 19, all sorts of numbers in the middle, between 10 and 20. The reason being, going back to this example, that count plus plus is actually not a single command. It's 3 of those. Takes the value of count, put it somewhere in a temporary place in the memory, advance the number, and then put it back in. If I have 2 threads running at the same time, one of them will take the number, let's say 1. The other one will do the same thing, get 1 as well. Both of them will advance to 2 and write back 2. So we get everything between 10 and 20 because of that. And I used to ask this question to see how well people, how comfortable people are with multi-threading. Because usually when people see that word, new thread, they'll lose everything. They don't remember anything about programming. It became undeterministic and hard to understand, and it's not. As I showed, it's very deterministic. Threading is deterministic. You just need to know the actual logic behind it, and the logic being anything between 10 and 20. Why I'm showing you this example? First of all, early in the morning, get you thinking. Other than that, threading is not that hard and can be deterministic if you want. Usually, when I teach unit testing, I start working with unit tests with a new guy in your team, I tend to find them looking for excuses not to unit test. The record was set by one guy in the second day of a unit testing course. He asked me, OK, that's nice. When can I not unit test? What scenarios won't work for me? And usually when seeing threads or something parallel or concurrent, they'll think, well, I'm not going to unit test this because there's no way in hell I can make it run in a clear deterministic way. And as you can see, it is deterministic. There's just a logic you have to understand. Now, we live in an interesting times. For those of you just joining the development world, you have no idea how hard it was for us before that. Multi-threaded was hard. More than that, it was very easy to understand because we only had one processor per machine. So only one command would run, well, roughly, one command will run at a single time. These days, even my father's machine have 4 cores. So it means that at least 4 things can run concurrently. We see new ways to write concurrency. .NET has the async await. Even C++ finally got threading and locks inside the language. And we see new languages emerge. Well, they are not new. They've been there all along, all the functional programming stuff. But now we're starting to use them because we have no choice. Because we want to use those additional CPUs in the right way. Because the free lunch is over. You know what the free lunch was? Yeah, the old guys, obviously. I knew for certain that if I write bad code, after 1 year, 2 years, Intel will come up with a new processor, and my code will run faster. And my software will improve magically as new computers emerge. And it stopped about, I don't know, 4 years ago. And now we don't get faster processors anymore, just more cores that we can use. So we need those things. We need to write this kind of code. The problem is unit testing haven't advanced that fast. This is my Hello World example. You might have seen it before, calculator. And you'll see something similar in every single tutorial about unit testing. No one talks about concurrency. No one explains how can I take this simple example and take it to the concurrent world where threads are jumping around and instructions start, wait for it, and then go back from the same point. And you can't do that. Not this way, at least. So we're in the middle of this concurrency parallel highway with this cart from back then, and it seems as if nothing changed. Unfortunately, concurrency is hard, much harder than writing single-threaded code. We have several paths of execution running at the same time. 2 threads, messing around at the same time, and all sets of new problems emerge. It's very hard to follow concurrent code. It's very hard to understand something that spawns something that will run eventually, go back, do something, or code that will execute, stop, run the same thread with another code, go back to my code, and continue running. It's a hard path to follow. Other than that, it seems non-deterministic, although it is to some extent if you know the rules. It means the code is harder. And if the code is harder, I want to unit test it. I want to make sure I don't have any bugs, at least me, personally. But it also seems harder to unit test it. And unit tests have a specific set of rules of what a good unit test is, what consists of a good unit test. It should be trustworthy. When a unit test fails, I want to know that a bug just entered the system or requirement changed, and that's it. I don't want my test to fail from time to time, which could happen when you play around with threads. You want the code to be readable and maintainable, which also concurrency doesn't help you much in that department. And you want your test to keep on running until a bug happens. And when faced with concurrency, usually those just fly out the window. And then I don't have a good unit test. And it became the test that fails from time to time. Yeah, you know that test? Some of us had those. You know how to solve a problem of a test that fails from time to time? Ignore it. Yeah. This is actually the second stage. The first stage being run it again, and then it passes. And then you get to ignore it, right? Because it has no meaning, that test, anymore. After a while, you have a bunch of tests you'll ignore or get used to your build being failing from time to time. And at that point, what you can do is just delete all your tests. They have no meaning whatsoever. So my objective in a team is to never have that test that passes from time to time, because that's a clear road to stop doing unit tests, or at least stop paying attention to them. Now, there are smells for those tests. I learned to discover when I have concurrency problems in my tests, just like code smells. Who knows about code smells? Yeah? Code smells are essentially something that tells me that there's something bad in my code. Just like if you walk to a room and you smell something bad, and you know there's a problem. But you know what happens after a few minutes or an hour? You forget about it. You forget that something smelled bad. And you sit in that room, listen to a lecture, I guess, something, or walk. And then someone new comes to the room. And the first thing he says, well, something smells bad here. And you look at him and say, yeah, I remember when I noticed that. And there are also sort of test smells which you can ignore after a while. And a new guy will notice them probably more than the guys working at that project. Usually the excuse has been, it always was like that, there's no way to test it in a good way, et cetera, et cetera. But I use them in another way. When I see one of those guys, I know that I need to dig in and understand the root cause, the problem. And inconsistent result being the first one. A test that passed and then failed and then passed and then failed usually means multi-threading. Because a unit test should be deterministic and very simple. No way for a unit test to decide to pass and then fail one after the one time and the other time do something completely different. And the other thing, the ugly sister of an inconsistent result is untraceable fail. My test will fail. The stack trace has nothing to do with the actual test. You know what happened there? I had the test, it ran, started a new thread or something. Usually mocking frameworks are involved because they keep a shared state and they manage to make that object live well after the test have ended. So the test ended, I have a thread running around, and then suddenly it comes back and crashes another completely different test. So this is the untraceable fail smell. Those are hard, because in order to really understand what happens there, I need to find the right scenario to run them, and then I take my, I don't know, 100 or 1,000 of unit tests, I run half of them. Does it fail? Okay. Then I run half of that. And I do a binary search, trying to find which test affect that test. Try to do it in an intelligent way by starting to understand what the hell happened with the stack trace, what caused it. But it's a tough job trying to find those. Other than that, long-running tests, a unit test should run less than a second. People said it's a rule of thumb, rules are meant to be broken, but once you see a test that runs several seconds, you either have an actual test that uses some sort of something outside the scope of the unit test, or you have concurrency. You're waiting for something to happen. So those are also good signs that you have a problem. And lastly, test freeze. John committed his changes. After half a day, someone else has committed their changes, opened the build server, noticed that it had been running for 5 hours. Usually, I have no business to run for 5 hours. And it means that one test just never ended. Luckily for us, most unit testing framework will stop us after a few minutes. But that's it's not that good, because it's also hard to find out why the hell it happened. What I usually do is try to see from the output which was the last test who ran. So it's either that test or the one that came directly afterwards that froze everything. And we have timeouts for that, exactly for that. Now, they are not alone. There are other smells which even make me more angry. First one being when you try to test codes that look similar to this code. I wrote this code several times. Think of it as a service I'm running. There's a loop that runs indefinitely, or at least until someone closes the application. It gets a new message every now and then when it has a new message. Process it or do something with it, and then go to sleep. Now a colleague of mine needed to test something similar to this code. Now you have a problem with this code. First of all, you have sleep. Second of all, it's infinite. It will run forever. So those two problems you need somehow to tackle. The infinite part he managed to do with using this variable in order to close it in the end. The thread.sleep, that was a problem. And so we came up with this solution. We have thread.sleep for 1 second. Why not do a sleep inside the test for twice as long? That is a problem. That is one of the smells. This I call sleep in test. You have no business in using sleep inside unit test. You shouldn't use sleep at all if you can avoid it. It has many problems. and usually says something about the design. Sometimes I use third party that there's no way around it. You usually see a comment, this is a workaround because I need whatever. But in a test, you have no business of using sleep. First of all, the test will run for way too long, at least 2 seconds in this case. And being .NET, it's not real time, it's at least 2 seconds. It could be more than that, depending on the load of your CPU. So the test runs for too long, and it's not deterministic. The test can fail from time to time, although it doesn't seem that way, because I'm using twice as much time to sleep, but because both of the times I'm sleeping are not deterministic, I've seen cases in which the tests return quicker than the actual production code, and the test will fail from time to time. It will be more rare, doesn't happen much, which only enable the developer to run the test again and say it passed. And it's very hard to investigate the failure, because when this test fails, I get to hello, and there's no direct connection between the reason I didn't get the last message and not waiting enough time. It's very hard to debug them. This is a very simple test. Your test will probably have more things inside. Your code probably is more complicated. And in this case, you'll have a tough time trying to understand why it failed, especially since we are time-based here. And I guarantee that with the debugger, you probably get it to work. And then you get logs in your unit test, which is not a good sign. So sleep is not a good idea. So I went to the guy and told him, this is not a good idea. Don't use sleep inside your tests. He said, what do you want me to do? The code is time-based. I need to do something. And I said, yeah, but sleep is a bad idea. He said, well, it works on my machine. I think this sign, works on my machine, should be hung above every door, every development room door, because it's true. But there's a good quote I found in a good book called 7 Concurrency Patterns in 7 Weeks. I wish I said that. In concurrent programming, if something bad can happen, it will in the worst possible moment. It's so true. And for worst possible moment, in our case, is a day before deployment, right? At night, 12 at night. That's where the test fell. And now we have 2 options. Ignore the test, or try to fix it in the middle of the night with your boss breathing down on your neck, and you're in a big rush, and you probably create more bugs along the way. So I explained that to that developer. He's a very bright guy and said, yo, I understood you. Don't use sleep. And he did the following. That is the true story. And this is not a dumb guy who did it. You have to be pretty smart to come up with this idea. Also, unit has become asynchronous, both Microsoft and NUnit and XUnit. So he was able to do that. And I asked him, why the hell, what were you thinking? He said, obviously, sleep keeps my thread busy. That way, I'm doing asynchronously delay. I said, no, that is not the right way. There are right ways. That's why I'm talking about it. And the first let's call it pattern, this is actual. I call them patterns, but they are not well-formed patterns, only the first one, because I didn't invent it. And the idea is to avoid the concurrency altogether. I do that using an actual pattern called humble object pattern from the XUnit patterns book. They didn't talk about concurrency, but it works for me. The idea is I have an object, it's very hard to initialize it, or it caused me a bunch of problems like an infinite loop. So I'll extract the logic from that object, the business logic which I want to test. I extract it out of the logic I don't want to test only this guy, and that one, well, I'll forget about it. Do only part of the whole thing, but I'll get to have a very simple to understand code to test. So in this case, what I can do is extract the part that actually does the logic, which in unit test, that's what I care about. So I'll take it out and put it in another class. I'm very bad with names. I call it message handler because it handles messages. That's my logic for it. And handle next message that does whatever happens there. And so the test is very simple now. All I need to do is create a fake object of the provider because I want to give it an actual message. For those of you who doesn't know what I'm doing here, I create a fake message provider and decide that when next message is called, return hello. That's it. That's all you have to know about this particular fake object. And I'll create a new message handler, pass it dependency injection, the fake message provider, and call the new method I just created. And the end. It's that simple. Who think I'm cheating? That's okay, I won't be offended, yeah. Someone's honest. Always at least one honest guy in the room, because that sounds weird. I just took a bunch of code, extracted whatever is convenient for me to test, and tested it, right? So we'll get to other patterns as well, don't worry. But it's not exactly cheating if I don't care about the whole message loop happening there. And in this case, I don't. There's a similar scenario. In this case, I have a bigger problem. I have one manager that creates a message, do something, and I queue the message inside this queue, and this queue is probably has a thread that takes the messages one by one and send them to the client, and the client does something with it. Similar problems, because the queue is concurrent by definition, it's multi-threaded by definition, and I don't want it in my test. I don't want any multi-threading if I can get away with it. And so the solution here, what I call test before, test after, is to split it to two different tests until I get to the queue and from that queue. The queue I'll test differently in another way later. But right now, I'm just testing the logic. And again, it's quite simple now that I told you how to do it, and everyone can write this message. I'll create the queue, won't start it, so the thread won't throw messages out just yet. And I'll create a new message and check that it's in the queue. I'll do a similar thing for the client, call it, you just got a new message, please do your calculations, and check that as well. And that's it. It's as simple as that. The queue I'll test in another unit test. Actually, when working at TypeMock, we used to do a bunch of customer support, both for sales, in order to sell more licenses, and to help our clients write better tests. And we had a client, a big company, and it was a friend of mine, close friend from way back. And we came to him, he had a similar problem. He had like client-server thing going on, wanted to test both of them, and we showed him this solution. And he looked at us and said, this is not what I was planning to do, because you're not testing my code. And we had a hard time explaining that we are testing your code, just unit test, and not the whole integration test, which is a completely different thing. But I can understand why you don't particularly like those kind of solutions, but they work for me. And I'll give you others to use as well. So I call them avoid concurrency patterns. That's the best possible solution if I can get away with it. If I can actually test the business logic, that's what I'm going to do. No concurrency, no problem. As I said, the problem is it doesn't always work, because obviously some of the business logic can be in the actual concurrent part. And yeah, and I don't test part of the code, and it's up to me to decide if that's a good idea or bad idea. So let's go to another thing. Here we have timers. I don't care for timers. I think we have like 6 of them right now in .NET, 5 or 6 different timers. And you need to know each and every one of them, the way they work. And to make things interesting, if you have universal app or plain .NET, they can be different, depending if you're using the UI-related timer. So it's a mess. And more than that, people don't understand something about timer. It uses the thread pool. Whenever the time elapses, well, equal or bigger than the time you requested it to, it will throw a new event in a new thread, which means that that timer can happen multiple times concurrently. If the timer is if I set the timer for 1 second, and I do some calculation that takes 5 seconds, I guarantee you'll have at least 2, probably 5 of those running at the same time. And people don't know it, and then you get to fix interesting bugs, because you're probably going to write something in that class with the timer and have no idea that you actually have a rest condition on your hands. So here we have the timer. And what usually people do when they have timer or timeouts, everything that time-based that I can affect in a test, I'll probably do something like this. This is not a good idea. I'll set the timer to as little as I can, probably use sleep as well. Not always, but usually. I saw with timeout people will set it to 0 and just assume that it will end immediately. That doesn't always work, depending on your implementation. And then I'll call the class, do something, and it will work most of the time. Not all of the time, though. And that's a problem as well. And I call it the set timeout or interval to 1 smell. If you see a test that's changing configuration or something in order for the timeouts to happen really fast, that's your problem. And it's time-based again, so it will work on your machine. It's how to investigate problem as well, because when you get a failure in the end of the test, you have no idea what happened in the middle. And usually will appear with thread sleep, which we already covered that subject. So what can I do with that guy? Very simple. Replace the timer with a fake object, or mock, for those of you who haven't listened to me yesterday. I don't like the word mock, so fake. So I'll replace the timer with a fake object, and I get to call it whenever I want. It's as simple as that. All I need to do is replace the timer. Using just mock or time mock, because timer doesn't have any interface and it's sealed, so I need to use heavy-duty tools here. I'll create a new fake timer, and this strange line in the middle basically tells the timer to elapse in this particular moment. That's it. It will happen here. That's the way to raise events in most of the mocking framework uses a similar way, because events are, you can't actually say which event you mean, and this is the trick. I used to work for that company, so I know what we did. This is a trick to get the actual name of the event so we can raise it. Try to use reflection with event, you'll understand how problematic it can get. So basically what this line does is raise the timer right here in a deterministic fashion. And I get to test the whole code, no splitting, breaking, or whatever. And it's fully deterministic. Either it passes or fails. That's it, all the time. Very nice. Unfortunately, I can't always do that. Mocking tools have limitations. For example, they won't tell you that, but even just mock and type mock can't fake all the objects. There's a library called mscorelib that you might have heard of. Most of the classes you use in every day come from there. Thread pool, one of them, thread another. And so they can't fake those. Well, they can, but it's tricky. They're not doing it at the moment either way. Other than that, depending on the programming language, we're using C# in order to fake a method with most mocking frameworks. And we need the method to be virtual or interface. Not always the case, especially when dealing with third party. I can change those. And there are special cases, as I said, mscorelib. And the solution, which I don't always like, but that's the least bad thing I can do, is wrap that class with another class and fake that class instead. And it will require me to change production code in ways that I won't feel too much comfortable with. For example, here we have a thread pool. And I wrap it with a thread pool wrapper, again, my name. And I try to write as little code as I can, because I don't want bugs in this guy. I can never test it in a unit test. I can test it in integration test, but that's a completely different ballgame. But I can't test it in a unit test, so I need to write as little code as I can. In this case, exact same method signature, just pass it in. And then I go to my production code and do a small sin. And instead of using a thread pool, oops, I use a thread pool wrapper. I'll change that line with that line. And that way, when getting to my test, this being my test, I can actually set a behavior on that thread pool. And this line, what essentially it says, is when someone calls this method, instead of calling the actual code, immediately invoke whatever someone asks you to call. So I get a thread pool that when you say QWalk item, immediately you get that method ran. And so in running thread, I don't run in thread anymore. I run in a synchronous manner in the same thread, and I get to the last line after it happened. So essentially what I did, I wrapped the guy I didn't like and then changed what he does in my test. But that means that in my production code, I need to use a bunch of wrappers inside the actual class. And it is a semi-common practice. People are using that idea, especially if you use one of the open source mocking frameworks because you have no choice. Well, that's all nice. But it still doesn't solve all of my problems. Because there's one thing with asynchronous that I can never test. It's like a philosophical question. How can I test that an asynchronous operation never happened? What does it mean never happened? I want to check that if I call someone and there's an error, then I don't get to, send a message down the line. But it's asynchronous. How can I do that? How much time can I wait to determine that it never happened? Will I wait for a second, a minute, a day? I don't know. It's impossible to test that an asynchronous operation never happened. And so what I would do in this case is have a piece of code that will run in a synchronous manner in my test, but asynchronous in the production code. And I can do that in several ways, depending on the code at hand. I can use preprocessor compiler definitions, if def. I can do all sorts of things, dependency injection being one way. And when using tasks, there's actually a cooler way to do that. This is the same example from before, only I'm using task instead of thread. And in the task, I'm running a bunch of stuff, which I want to run in my test in a synchronous manner. So let's see that example. Here we go. What I did, everybody can see that in the back? OK. So what do we have here? We have the test. Class T test. No, I don't care about you guys. Here we go. There's a bad test. The bad test will fail most of the time. Basically, being a trusting kind of guy, I'll create a fake object, and I'll create that guy, and say when the event of a new message was raised, then I just mark it as it was raised, it's OK. I'll call start, and I'll check if it was called. This test will fail most of the time. Obviously, this being demo, so 80% of the time then, because I always get something work differently. Yeah, OK, failed. Obviously, a search rule failed. Well, now I need to dig in my code because I have no idea what the reason was that it failed. Again, there's a bad way to do that, and that's to use thread sleep, and we covered that topic. What I actually did in order to do that, because I know I'm using task inside, I've created a new task scheduler. Everybody know what task scheduler is? So basically, I created a new task scheduler. And when someone calls queue task to that task scheduler, it will try to execute that task immediately. And again, whenever try to do inline, same thing. Run it immediately, and maximum concurrency level being 1. Very simple class. If I manage to somehow get this class inside my production code, I'll run in a single thread, because the task will be executed in the same thread. That's what it does. So let's see what I can do. I have this class here with the start method, and I'm using the task scheduler current. So let's change task scheduler current, and it can be done quite easily. I was very happy to find it this way. What I'll do, I'll run the client code in my test inside a different task using the new task scheduler. So what happens here? This will run in a single thread, right? And I just set this task scheduler to be my task scheduler as well for the other one, the next task in line that will also try to get the current scheduler. I impacted the production code from within my test without changing the production code. You can do that with reflection as well, but I find it to be a more elegant solution. than going and changing the task scheduler, the default task scheduler using reflection. Also, you might get burnt if you don't switch it back, if some of your tests do depend on it running in a different thread. Everybody got that? Yeah, it's a cool trick. I use it in some of my tests because it just works. Only problem, if someone decides one day to change the task to a thread pool or something else, then I'll have problems. So as long as using task, I can do. It will continue to work. So those are the ways, what I call syncing test. The test is synchronous, the code is asynchronous. And there are many ways to do that, and I'm sure everyone here can think at least of one way to do it, either by using, as I said, dependency injection, preprocessor definitions, pass a delegate. I did that once. I had a delegate that could be asynchronous or synchronous. I decided in the test to pass my own, just run the code, and all the other run in another task. And there are many other ways, and I'm sure you can find them depending on the scenario you're trying to test. So those are nice. As I said, there are two ways to do that. Fake and sync. Fake the asynchronous object, and your tests become synchronous. And use something in order to run the test differently than the actual production code. Now, all of those were me avoiding the problem. All of those were basically looking at the problem I have and making a real effort not to face it, right? Run everything in a sequence way, and it's good. That's the way unit is supposed to run, in one thread, if I can. But sometimes I can't. Sometimes I need to run the test in a concurrent manner. No way around it. I just have to. And in this case, I still want the test to be predictable because it's a unit test. Now, there are two ways I tend to find myself returning to all the time. First being signaled. I call it the signal pattern. I don't know. And the idea is to find a hook, someplace I can hook into the test using a fake object, put there a wait handle, and wait for it to happen, and then continue with my test. Essentially, if I have this very difficult calculation, A plus B, and then I put it and do something with it, I know something. There's another class here that calls a method, and I can hook up to that method using fake objects. So essentially, what happens here, let's see, yep. I create a fake other class. I'm allowed to. And I say when do something is called, that method, which I know happens after the calculation, which I'm interested of seeing, invoke wait handle set. And I have a wait handle here, and I call this asynchronous method, and then I wait. Now, it's very similar to timer. Those of you would say, yeah, that's exactly like timer. In a way, it is, because the test will fail. If it will fail, it will take a very long time. 10 seconds in unit testing terms are like forever. And I won't know why it failed. I have no idea why the result wasn't set. I make my best using some messages in order for future me to understand why the hell it stopped working. But other than that, I don't have much I can do with it, because it still runs in a concurrent method. So two things ran, one of them didn't do it, and now I need to understand why. And it's very hard to understand from unit tests, but I have no choice in this particular method. So I'll do that. And if the test passes, it's a very quick test. I don't wait, like with sleep. I don't wait for 10 seconds here every time, just when it fails. And when it fails, it's OK, because it's not supposed to happen all the time. I want it to hurt enough for people to fix the test. So I'm good with waiting for 10 seconds when it fails. You only have to see it twice in order to be really frustrated and fix it. So that's a good thing. So that's the signal patterns. Another way, this actually, a colleague of mine invented that one. We started unit testing, had a lot of concurrency. We didn't know what we were doing at the time. And he came up with a method. He called it wait until condition met. I like to call it busy assert. It's more unit testing name. But the idea was I'll run a busy loop until something happens or a timeout is reached. That's another way. If I can't hook up to an event that tell me the calculation was over, that's what I'll do. I'll use busy assert. And busy assert will essentially wait until this thing happens. It will do it 50 times with 100 milliseconds between each try, because I want to use sleep. Otherwise, my CPU will fly out the roof. So, and if it fails, I'll probably give it a good, very good error message, because it will be hard to find it. This one will fail without any connection to the other things in the test. Something in the background running another thread didn't get to this point after 5 seconds. More than 5 seconds, at least 5 seconds. Now, busy asserts is very easy to implement.
NUnit actually has one.
Mm-hmm.
NUnit has one.
NUnit, I didn't know that.
Yeah, you do assert and then your condition after, and you could give it a polling.
Ah, that's good to know. I'll look it up.
Because we had our own poll until I discovered that.
Oh, OK. So that makes the following example completely useless. That's OK. I don't mind. Yeah, I'll show it either way. We have the time. Basically, busy assert looks something in. There we go. That's how my colleague implemented it, and it's very simple code. You probably want to put some error handling along the way, but that's essentially what he did, and probably NUnit as well. I'll check that. Really, yeah, learn something new. That's good. Because, yeah, and we got to this one before all the others because it's more, it looks like the right way when you begin with the concurrency, waiting for it, until you find out that it's very hard to understand why the hell it starts working. That's how I found out about the other ways of doing it. Because I started with this one. This one is what you would think to use when you have multi-threading concurrency because it's more logical. I have an assert. Let's have an assert that waits. And it's good. And again, if it passes, it won't take that long. But if it fails, it will take a long time. And again, I'm good with that because I want people to feel actual pain when the test fails, so they'll fix it. So those group I call the synchronized test patterns. I try to synchronize concurrency. It will be harder to investigate the failures, as well as you can attest that the call was not made, as I said before. And it will run for too long. But unfortunately, from time to time, I need to use it. No way around it. But usually, this is the last result. That's the last thing I'll try, if I didn't manage to use the other ones. Now, all of this is good and nice. Not bad. But I guess when you sign up, when you came for this lecture, you wanted to see how to unit test for concurrency problems, right? Who thought I'm going to talk about it? No one? Whoa, yeah, you're embarrassed to say it. That's OK. That's what people think I'm going to talk about. And you know, you're right, I am going to talk about it. But it's very difficult to test for concurrency problems because of the nature of concurrency problems. Usually you have 3 problems you can have in concurrency. You can either have a deadlock, race condition, or starvation. That's the 3 that we are trying to catch. And it's very hard to do that using a unit test. It's not equipped to do that. When I worked for a company, a friend of mine, he had a task. He needed to write a new client, TCP client, which is very odd for .NET, but we had the reasons. And he wanted to test that if he has 50 clients, they still work at the same time. And he had a big test that started 50 clients, threw a bunch of messages, and saw that all the messages got to the clients. This is a very nice test. It's a feel good test. As long as it passes, I'm fine, and I know that I'm good. Once it fails, you have no way of understanding why the hell it happened, because so many things happened there. And again, logs, the only way to actually understand, and it will fail from time to time. And having it pass doesn't mean anything. Now, in my past, before I worked in a mocking framework for TypeMock, we tried to create a similar component to find race conditions and deadlocks. We were, well, we were successful to begin with, and then the project was canceled because it's very hard. Essentially, in order to find deadlocks, we needed to run every single execution path. If I have 2 threads and 2 locks, it means that I have an execution tree of at least 4 levels. 1 thread got to the lock, 2nd thread got to the lock, 1st thread got in, 2nd waits. Now the first one released that lock, got to the 2nd lock, got in. Now let's try the same. Now the 2nd one got in, and well, we ran out of memory and execution time doing it. And there are tools there. There are tools. Microsoft Research had a bunch of them. Nothing actually became a product in the end, which is unfortunate. Chess, if you know. And we had Racer trying to do the same thing in .NET. So no good news in that department, unfortunately. What I can suggest is writing unit tests, which I usually tend to write after I found the bug. My code has a bug. Two things run at the same time, I get a deadlock. Then I'll try to write a test, at least not to see the bug again. If I have somewhere that I suspect that has this problem, I'll try the same tricks I'm going to show you. But the problem with them, they are very specific. They are tightly coupled to the code, which is not a good thing in a unit test. But they will at least ensure that you're not repeating your bugs, because progress is making you mistakes. So the first way, I want to test that a method is actually asynchronous. And we had this problem. We will send messages, and we found out that it took them forever to get there. And then we found out that our client only sent 1 message, wait for the response. It wasn't actual asynchronous, it wasn't multi-threaded, although we did spawn a bunch of threads there. Nothing happened because we had locks all over the place. Not a good thing. So what I'll do is I'll start the method I'm trying to test, hook up to some fake object along the way, and make it freeze. I'll hold it. Don't let it get away and continue running. And then I'll run the method again. If I manage to get to the end of the test, it means it's asynchronous. If not, well, I have a deadlock on my end. Well, not a deadlock, but a starvation, probably. And I have a nice example with that. And we had this problem. We had a bunch of clients talking with each other in a synchronous manner, big performance hit due to that fact. And it wasn't nice, and yeah, good. So, here we go. Here we have the test. As you can see, I'm using timeout. Don't use it a lot in tests. I don't think it's a good practice. But this test, when it fails, it will freeze the whole execution, because that's the way it fails. Nothing gets through. Unless you manage to put some timeouts along in your production code, you want your test to have a timeout. Otherwise, after a day or two, you notice that you're not running anymore. Your build server is stuck with this test. And what I'll do, there's a fake client here, and I say when you call send, then you're going to wait. And I use a counting event to count how many times I got into this method as well. And here I call send, okay? And after I call send, I'll call set. And this is a simple test. Now I get to more complicated tests. Just call send twice. If I manage to get to this line, then my operation is actually asynchronous, got it twice, and I see that I reached the event at least twice, and I'm good. Okay? That's a very simple way to do that. I'll just run it twice. Now, we noticed something about those tests when we started writing them, because we had a lot of problem there in that project. We noticed that we have another problem. Some of the calls were actual asynchronous, but they would tend to freeze our tests as well, because they waited for something to happen. And then we invented something, well, not particularly proud of it, but it does the job, which we call, where is it? Let's look for it. In other thread. Running other thread is us trying to be smart with it. because we didn't want the actual call to cause the application to freeze. So we ran it in another thread. Now the problem with running another thread that if it manages to get an exception, I have a problem. And so what we did, we wrote a base class for our tests. And if we'll get an exception, I'll write something that said, I got an exception. This is a shared state between tests, not a good thing, but sometimes you don't have any option. And during test cleanup, a method that runs after each and every single test, I'll check if I have an exception. If I do, I'll raise an assertion problem. You had a failure in the test. Because we noticed in the beginning that the test would pass, but they got exception all over the place. And that way, we managed to get a stack trace from another thread. That's us taking exception one thread, putting it in our thread, and through the unit testing framework out. It could be improved, but essentially that's what we did. And we did it especially for the next scenario, testing for deadlocks. The big problem we get from time to time. I want to test in a deterministic method that I have deadlock. And for that, I need to understand, I have to have intimate understanding of my code, because what I want to do is a similar thing. I want to have two threads executing, stomp both of them before the place I think a deadlock will happen, or if I got a bug, the place I know that a deadlock occurred, and then I release both of them in the same time to crash into one another. And this is the actual code. And again, I use run in other thread because this call is not asynchronous. And I run this one in another thread. That's me in the test running two threads in order to simulate the actual real-world scenario. And you can argue that this is actually not a unit test, integration test, but I don't really care. I needed to test it. And I get both of them. When you call those dependencies, it will wait. And so they'll try and catch the lock, and they'll wait. And then I call set and throw them at one another. And if they have a deadlock, then I'll get the timeout. That's up there, just to make sure that I don't get my server stuck because of this test. OK? But I need to know exactly what happens inside my code. This is tightly coupled with the code. I would only use that where I have an actual bug, or I fear an actual bug, and I want to make sure it doesn't return after a few releases. And I have used that from time to time, but not that much. Now, what did we see today? Basically, there are 4 ways to deal with concurrency. You can avoid it altogether, which is my preferred way. You can run it in a single thread. You can synchronize the concurrency in order to have your tests still be deterministic. And there are those guys which are testing the actual concurrency problems on their own. What I usually do when someone comes with this kind of problem, I say you have 3 options. I don't start with this. I'll say you have 3 options. You have your method. Can you run it without the multi-threading part, without the concurrency part? If the answer is yes, go for it. Can you somehow synchronize your run? If the answer is yes, do that as well. If not, busy assert or wait handle is your way. Those are the 3 ways of doing it. If it's trying to test that something doesn't happen, you only have 2 options, the first 2. Any questions? Do you want me to repeat something?
Could you please return to the previous slide?
This one?
Yeah.
Oh, this one. Yeah, this is available on SlideShare, and the code is on GitHub, both of them under Dror Helper. So you can use that. Well, usually people have a bunch of questions, but feel free to come to me afterwards. That's OK as well. Thank you very much for listening. Good morning, everyone. I appreciate you coming this early in the morning. Not so easy for a software developer waking up before 9 in the morning. And I know that. I feel your pain. So we are here to talk about concurrency in unit testing. Before that, for those of you, I see a lot of familiar faces from the last 2 days. So shortly, I'm a consultant at Code Value. Been developing software since 2002. At least been paid for it since 2002. In my past, I worked for TypeMock, a company that specializes in unit testing and create a mocking tool, which I talked about yesterday quite enough. So we'll put it there. And I develop code using test-driven development for about any project I get, because that's the way my mind works. After a while, I can't do that any other way. And I'm a big believer in clean code and anything else that can help us developers write better code with less bugs, or any bugs for that matter. I have a blog at blog.drorhelper.com. Now, let's do an exercise before we start. This is actually something I used to give applicants. This is an actual test I used to do, because people come to a job interview, they are a bit stressed out, and you want to give them something pretty simple to start with. And I would show them this code or something similar to it. And I see, by your looks, that's exactly the make it run in a clear, deterministic way. And as you can see, it is deterministic. There's just a logic you have to understand. Now, we live in interesting times. For those of you just joining the development world, you have no idea how hard it was for us before that. Multi-threaded was hard. More than that, it was very easy to understand because we only had one processor per machine. So only one command would run, well, roughly, one command will run at a single time. These days, even my father's machine have 4 cores. So it means that at least 4 things can run concurrently. We see new ways to write concurrency. .NET has the async await. Even C++ finally got threading and locks inside the language. And we see new languages emerge. Well, they are not new. They've been there all along, all the functional programming stuff. But now we're starting to use them because we have no choice. Because we want to use those additional CPUs in the right way. Because the free lunch is over. You know what the free lunch was? Yeah, the old guys, obviously. I knew for certain that if I write bad code, after 1 year, 2 years, Intel will come up with a new processor, and my code will run faster. And my software will improve magically as new computers emerge. And it stopped about, I don't know, 4 years ago. And now we don't get faster processors anymore, just more cores that we can use. So we need those things. We need to write this kind of code. The problem is unit testing haven't advanced that fast. Look, I would get because people think there's a trick. So the first thing I say, what this code does, no trick. I promise you no trick. So what does this code do? What, if I'll print count in the end of it, what will I get? Well, we are starting from 0 till 10, probably, this case, yeah, 10. So that's good enough. Yeah, that is the right answer. And then I'll show him the following code and ask him, now what do I get? And in that moment, after being very calm from the first answering this question, they'll see that. And once threads get into the equation, now we don't know, right? Who will think that the output is undefined? I can't possibly know. Anyone? You can raise your hands. You're not in a job interview, so. Well, true thing is the output is well-defined, very well-defined. Basically, most of the time I'll get 20 because I'm running it twice. And some of the time, depending on my computer, changes, I'll get something between 10 and 20. And to prove that, I'll run that code. And as you can see, most of the time it's 20, and I get 11, 14, 19, all sorts of numbers in the middle, between 10 and 20. The reason being, going back to this example, that count ++ is actually not a single command. It's 3 of those. Takes the value of count, put it somewhere. This is my hello world example. You might have seen it before, calculator. And you know, you'll see something similar in every single tutorial about unit testing. No one talks about concurrency. No one explains how can I take this simple example and take it to the concurrent world where threads are jumping around and instructions start, wait for it, and then go back from the same point. And you can't do that. not this way at least. So we're in the middle of this concurrency parallel highway with this cart from back then, and it seems as if nothing changed. Unfortunately, concurrency is hard, much harder than writing single-threaded code. We have several paths of execution running at the same time. 2 threads, messing around at the same time, and all sets of new problems emerge. It's very hard to follow concurrent code. It's very hard to understand something that spawns something that will run eventually, go back, do something, or code that will execute, stop, run the same thread with another code, go back to my code, and continue running. It's a hard path to follow. Other than that, it seems non-deterministic, although it is to some extent if you know the rules. It means the code is harder. And if the code is harder, I want to unit test it. I want to make sure I don't have any bugs, at least me, personally. But it also seems harder to unit test it. And unit tests have a specific set of rules of what a good unit test is in a temporary place in the memory. Advance the number, and then put it back in. If I have 2 threads running at the same time, one of them will take the number, let's say 1. The other one will do the same thing, get 1 as well. Both of them will advance to 2 and write back 2. So we get everything between 10 and 20 because of that. And I used to ask this question to see how well how comfortable people are with multi-threading. Because usually when people see that word, new thread, they'll lose everything. They don't remember anything about programming. It became undeterministic and hard to understand, and it's not. As I showed you, it's very deterministic. Threading is deterministic. You just need to know the actual logic behind it, and the logic being anything between 10 and 20. Why I'm showing you this example? First of all, early in the morning, get you thinking. Other than that, threading is not that hard and can be deterministic if you want. Usually, when I teach unit testing, I start working with unit tests with a new guy in your team, I tend to find them looking for excuses not to unit test. The record was set by one guy in the second day of a unit testing course. He asked me, OK, that's nice. When can I not unit test? What scenarios won't work for me? And usually when seeing threads or something parallel or concurrent, they'll think, well, I'm not going to unit test this because there's no way in hell I can